Hello, I'm back. We're doing experiment 3 today, which is the synthesis of a compound. The compound we are going to make is magnesium oxide. So our apparatus is we are going to have a clay triangle, a crucible. I'm using a metal crucible, and that will fit right into our clay triangle. And we will need a tripod. So here is a tripod, and then the clay triangle sits on top of the tripod, and we have our Bunsen burner. All right, now in order to light our Bunsen burner, we will have to put our gas on and have some sort of a striker or a match in order to light it. All right, so for this experiment, we had to weigh our crucible. For this run, I will give you the mass of the crucible. It is 14.2050 grams. That was the empty crucible. And then I added magnesium. So here is our bottle of magnesium. And I put in about 0.3. You will have to calculate it exactly. And our mass, I don't know if you're going to be able to see inside of here, but I have magnesium inside the crucible, and then I weighed it, and it has a mass of 14.4975 grams. So we have about 0.3 grams in here, and you will have that number to the correct number of sig figs on your report sheet. All right, so now we have to burn it, and when we burn the magnesium, and then we're going to weigh it again. Now, my question I always ask is, all right, so after we're done and we have burnt this and then we're going to weigh it again, is it going to weigh more or is it going to weigh less? And when you burn something, you're used to it always weighing less. When you burn a metal, we have our conservation of mass. All right, and so what we're starting with is magnesium. What we're going to get is magnesium oxide, which means it had to add oxygen. So when we are finished, the mass of this is going to be more than the mass that we have started with, because the magnesium is going to take in the oxygen from air. All right, so now I'm going to light my Bunsen burner and I'm going to burn it. And I'm going to show you what that looks like. If possible. So first I'm going to light the Bunsen burner. All right, so I have my striker, and the striker, when you buy them at a welding store, they have this little cap on them. I am not a fan of the cap. All right, so I take the caps off of mine, and so that I can fit it right into the hole, and I can push down and I can get lots of sparks. And so you have to then turn the gas on. Straight out is on. All right, before we do that, I'll show you the bottom. All right, so the bottom has a hole. So you have the hole open for air to go in, or you can close it. All right, and so when you have it open, you're going to have lots of oxygen. You're going to have lots of combustion. You're going to have a higher heat. You're going to have a blue inner cone of your flame, which I will show you. When you have it closed, you have limited the oxygen, and so you're going to have a luminous flame. It's going to look like a campfire. All right, so let's light it. It's easier to light when you have less air going through there, blowing through. And so let's go ahead and turn the gas on, and we're going to light it and show you the luminous flame. All right, so there is your luminous flame. You would never heat anything with a luminous flame. It is going to have incomplete combustion because it is lacking air going through there. It's going to actually deposit carbon on anything you heat with that flame. So you never heat with a flame that you can see that looks like a campfire. So you have to open the air valve. All right, and so I don't know if you can see the inner cone. All right, but let's get it closer. All right, and so we have our inner cone. So the tip of that inner cone is the hottest part of the flame. And I have the tripod set up very nice with this Bunsen burner, that the bottom of that crucible hits that inner cone. All right, and so I'm going to slide this underneath this. We're going to start heating our magnesium, and I'll see if I can get the video of the inside of the crucible. Alright, so it is burning the magnesium. Let's see if I can tilt this in a way that we can see it better. Alright, so it's starting to burn, so maybe we can see it better here. Alright, and so we are burning the magnesium. Alright, many places will say online to have that covered so that you don't lose anything coming out the top. In the past, when we've done it with the top on, it was very difficult to get it to burn completely, and so we do this and get very good results by just leaving the cover off, and we will burn the magnesium. All right, and so magnesium is extremely hot. If you have a magnesium fire, you basically just have to wait for it to go out. You can cover it with sand. You never put water on a metal fire. It is so hot it converts the water into hydrogen and oxygen, and you have nice explosions if you try to put out a metal fire with water. Alright, so this takes a while. You can still see the glowing. The magnesium is going to burn for a while, so we're going to let this burn for a few minutes, and then I'll go through some of the calculations on the board. Alright, so this is experiment 3, which is synthesis of a compound, and that compound is magnesium oxide. Now, air is mostly nitrogen. It's 78% nitrogen, 21% oxygen, and 1% other gases. All right, and so when you do this combustion of magnesium, like we just showed there, you're going to have the magnesium react with both oxygen, which is diatomic and written as O2, oxygen gas is diatomic, nitrogen gas also diatomic, written N2. All right, and so we have our reaction. So our magnesium reacts with oxygen to give magnesium oxide. The magnesium reacts with nitrogen to give magnesium nitride. If you get out your periodic table, you see that magnesium is in the +2 column. And you also see that oxygen is in the -2 column. And so when you make that binary compound, the magnesium at +2, the oxygen at -2, it is a 1-to-1 magnesium to oxygen ratio, and so you have MgO. If you look at magnesium again on the periodic table, it's in the +2 column. The nitrogen is in the -3 column, and so you have a +2 and a -3. The common factor is 6. You need 3 +2s for +6. You need 2 -3s for -6. And to write that as a formula, you write it Mg3N2 for your 3 magnesiums at +2 each, so that is +6, and your nitrogens at -3 each, and so that is -6. All right, now our compound that we want to make is magnesium oxide, not magnesium nitride. And so there is a nice reaction that when you take your magnesium nitride and you react that with water, it is going to produce ammonia gas and magnesium oxide. Actually, it makes magnesium hydroxide, and then when you heat it, that releases water and gives you magnesium oxide. All right, and so we are going to kind of do that all in the same step. We're going to get our magnesium oxide. So now we have converted all of our magnesium nitride into magnesium oxide. So some of the calculations that we're going to do in this lab, we're going to have to convert to moles. So equation that's extremely important that you should already know, and if you don't know, units will get you the answer as well. But if you take your mass in grams divided by your molar mass, which is grams per mole, you get moles. So the equation is mass, lowercase m, over molar mass, capital M sub little m, and that's equal to moles, which has the symbol of N. All right, so I talked about it a little bit. This is kind of a strange thing for most people when you say you're going to burn the magnesium, and it's going to get it to be a larger mass. That is due to the conservation of mass, which states your mass of reactants equals your mass of product. So back over to forming our magnesium oxide, we weighed out magnesium. We are going to burn it in air, which means we're going to add oxygen to that magnesium to make magnesium oxide. And so the mass of the magnesium plus the mass of the oxygen equals the mass of the magnesium oxide. And so it will weigh more than the initial mass of magnesium. All right, now to find the theoretical percent magnesium in magnesium oxide, you just go to the periodic table, you find your molar mass of magnesium, and then you divide by the molar mass of magnesium oxide and multiply by 100, and that will give you the theoretical percent magnesium in magnesium oxide. All right, to get the experimental mass, we already have that. We weighed out our magnesium. To get our mass of magnesium oxide, that is what we are doing right now. All right, and so, well, let's show the, all right, so what we have now is a white solid, nothing glowing red, nothing sparking, and all the magnesium has been converted to both magnesium oxide, which is what we want, and magnesium nitride. All right, and so now I will take this off. All right, and our lab benches are made to be able to hold very, very hot things like this very hot metal crucible. All right, and so if you put this on a wooden table, you're going to get smoke. You're going to have a nice hole burnt into your wooden table. I'm letting it cool off a little bit before I put it down, but it is not going to hurt the table. All right, so I will put it down now, and I'm going to add my water. So any magnesium nitride is now going to be converted into magnesium oxide, and the other product there is ammonia. So I'm going to add about 10 or 20 drops. All right, and so I see some fumes coming up out of the crucible, and you probably can't see it. All right, and then if I waft, this is how you smell in chemistry. You don't stick your nose over it and breathe it in. You will waft the fumes over to your nose. You will get the smell of ammonia, which is a cleaner. All right, and so now that we've added our water, we've got any magnesium nitride now converted to magnesium oxide. All right, and so I'll make sure we have plenty of water, because all we're going to do is boil off the water. So I'll add a few more drops of water. Make sure that it has all been reacted completely. So it's just deionized water I'm adding. All right, so so any magnesium oxide with water would be converted to magnesium hydroxide, and then once you heat that up, any magnesium oxide would be converted to magnesium oxide and water. And so you can hear it boiling. So the water is boiling out. All right, so we'll put that in there, let that, make sure that is bone dry. And I'm going to write the numbers on the board. You probably won't be able to see them, but I can't write and hold the paper. All right, so for run 1 that I did prior to recording this run 3, the mass of crucible 14.2075 grams. The mass of the crucible in magnesium was 14.4798 grams. And the mass of magnesium oxide in crucible was 14.6477 grams. All right, and so the first one is the mass of the crucible that's empty. The second one is the mass of the crucible with magnesium. The third one is the magnesium crucible and magnesium oxide. All right, so now this is sufficiently dry. And now we have to cool it before we can weigh it. So now I'm going to cool it off a little bit. I'll put it back over here again. We're going to let that cool. And once it's cooled, we will weigh it. We will have our final data point. And we are done with this experiment. In run 2, the crucible weighed 13.6639 grams. The mass of crucible of magnesium was 14.0522 grams. And the mass of crucible and magnesium oxide was 14.2928 grams. All right, and so the one we're doing now, we started with our crucible, which was 14.2050 grams. The crucible of magnesium was 14.4975 grams. And so now once we weigh our crucible and our magnesium oxide, once it has cooled, we will then have our final data point. So we turn off Bunsen burner. Now, if a Bunsen burner is hot on the bottom, you have a defective Bunsen burner. You should always be able to hold this. This is cool. It is not hot at all. And so this Bunsen burner is working properly. Do not touch that metal tripod for a long time. It is very, very, very hot, and it's going to stay hot for quite a while. All right. So again, we want to have our crucible at room temperature. All right, and you would want to touch the top. The top will be the coolest. You were heating it from the bottom. All right, and so you would touch it lightly to see if it has been cooled enough to the touch. I do not feel heat here. All right, so then I add a second finger, and it is warm. It is not ready to be weighed at this point. It is not hot enough to burn my fingers, but it is definitely warmer than room temperature. All right. So if we look at our report sheet, all right. So we're going to have our mass of magnesium. We'll go back to the board here, and we will go through a few of the calculations while it is cooling. All right, so we have our mass of magnesium and we have our mass of magnesium oxide. All right, so here are the numbers. Here's run 1. So again, the first number is the mass of just the crucible. The second one is the crucible plus magnesium. And the last one is the crucible plus the magnesium oxide. So there's your numbers for run 1. There are your numbers for run 2, and for run 3, the one we are doing now, here are the first two numbers. That's the crucible and magnesium. All right, and so if we know the mass of magnesium, we do from our data, simply do the subtraction, and we know the mass of the magnesium oxide. Again, we can get that from our data. From the conservation of mass, we know that the mass of magnesium plus the mass of oxygen equals the mass of magnesium oxide. And so to get your mass percent, what you're going to take is you're going to take your mass of magnesium divided by your mass of magnesium oxide times 100 to get you a percent. And now since magnesium oxide is only magnesium and oxygen, you can subtract from 100 to get the mass percent of the oxygen. All right, so I think that we are going to be now ready to weigh. All right, the balance is over here. All right, and so the crucible is at room temperature. We make sure that the balance is at 0. We put it on, we close the door, we grab a pen, and we write down our number. And the number is 14.6840 grams. And that is 14.6840 grams. And that is the end of experiment 3, synthesis of a compound.